Hearing the sound is good, but knowing what you are doing is the best. Because the approach that we have is that me too have been a victim of it. We are going to get there. We just set equalizer to suit us or the way they used to set it normally. We don't know that all those things, each one of those equalizers or fades, they have what they are doing. They have a function and they have a frequency they respond to. So which frequency are you dealing with? You have to know the frequency you are dealing with. Is it 1K? Is it 10K? Is it 50 hertz? Or is it 63 or 25K hertz that you are dealing with? You have to know. So you can either boost or cut. This is also known as peak or dip or by shelving. Boost or cut respectively increase and decrease the level of a band of frequency around a certain frequency. Mind you, certain frequency. I'm still laying the point that you must know your spectrum frequency response. Which frequency are you dealing with? What is the issue you are having in your mix? Which frequency is giving you offensive sound? But are you able to identify it? Do you know where that offensive sound is coming from the keyboard? Can you identify it? Fine, if you can identify it, that's the first step. Then you go to your EQ and you cut down. You cut it down. If your voice is shallow, or maybe you have too much of sibilance on your microphone, which frequency is responsible? You look towards from the 10K to 16K to 20K. That's where we have those sibilance and ease. You have to go there and cut down. Yeah, cut down. So, but if you don't understand this frequency response of a thing, it will be very difficult, I'm repeating it, very difficult for you to operate an equalizer and operate it successfully. Because you must know what you are equaling to what. So the frequency at which maximum boost or cut occur, this type of equalizer EQ is often referred to as a bell curve due to the shape of the frequency response. Now, shelving. This is an application of the digital mixer where somebody is trying to work on some particular frequency around there. Can you see my mouse? And around here. He's trying to shelve some frequency. And by doing that, he tried to shelve the high frequency from around, if I look at this, maybe around 10 or 8K here. And the low, and if I'm seeing it also very well, around 50, is it 50 or 63? Yes. I think it's around 80. Yes, 80. Is shelving, is cutting off any bail, anything from that end. That's why you see this shelving. So shelving also increase or decrease amplitude, but by a fixed amount, gradually filtering out or shelving at the maximum selected level when the chosen, called tune over or cut off. Yes, cut off frequency is reached. The stop frequency is the point at which the gain stops increasing or decreasing. Just like you have this arrow, those are the stop frequency. The stop frequency here is 80K, while the stop frequency here should be around after 10K, that should be around 16K. Yes, 12 or 16K. It should be around that area. That's where you can see my mouse moving around there. That's where the stop frequency for high, yeah, while the low is here around 8. Now, at level, when the stop frequency is speed, that this is what you want your frequency to stop here for low, and you want frequency to, then it means that you have a range to work with. So your range that you are going to work with will be between 10K here and 80K. This particular setup, to me, I can say categorically is for voice setting. The diagram you are seeing here is for voice setting. For microphone voice setting, either male or female, this will accommodate it. These two frequencies shelving will accommodate it for a male voice and for a female voice. Now, you can now be creative with it and adjust 5K, 3K. You can cut down at around 1K. You can boost and tighten up at around 4K here. This 8K, this 10, 4 should be around there. You can add some sibilance, some presence at around maybe 8, between 8 and 9 and 10K. You can add, you can now be creative with your EQ. In other words, with boost and cut EQ, when a frequency is selected for boost or cut by certain amplitude, that frequency is the one most affected. Adjacent frequencies are also affected, but by gradually lessening changes in level with shelving EQ. All frequencies above or below the selected frequency are equally increased or decreased by the level of selection. Now, what I just explained before, that if you want to cut down on 1K and you select 1K around here, see where my mouse is, by the time you draw your 1K down, it will also draw down a bit of 3K, and from 3K to 2K, or 2K and 3K, 4K. So it means that particular frequency you are working upon, some other frequencies that are very close to it will also be worked upon. So it will give you a range. But the particular one you selected will be where the emphasis is, where the point is. That's what they are being explained. It's being explained to us here. Now, filters. Let's move to filters. The filter is the simplest form of equalizer in a digital console. You can only have this type of display on digital console. We are dealing with digital. I know most of us are very used to the analog, EQ, and all those stuff. But here we are dealing with digital. And from here, the filter is the simplest form of equalizer, even for beginner. Some people won't call it an equalizer, but refer to it specifically as a filter. That isn't important. However, the function of the filter is very similar, as is the way it is used. A filter removes band of frequency. It never boosts. Can you understand that? It cut off completely. There are 5 principal type of filters that you will understand in the digital mix console. Low pass, where low frequency are allowed. Where low frequency are allowed. Yes, low pass, where low frequency are allowed to pass through, but high frequency are reduced. High frequency are reduced. So you can see the way that works. You can see how it works. So from that, you have the next one, high pass. Yes, high pass. What they are trying to explain on the low pass is about the level, which is the attenuated level. So also is the high pass, where high frequency are allowed to pass through, but low frequency are reduced in level. Then the band pass, where both low and high frequency are attenuated. Mid frequency are allowed to go through. Then we have band stop, where both low and high frequency are allowed to pass, but a region of mid band is attenuated. Notch frequency, notch filter, a very narrow band stop filter, taking out a small range of frequency. Now, all these things we talk about, you can see them in this picture. From here, you can see your low pass. You cut it from here. This frequency, we always have our 10K, from 10K to 20K here. That's for low pass. So they have cut out the high to allow the low to pass. This is how the low is passing. When they get to this place, it's cut. Low cannot enter this frequency. And this one, high, they allow high to pass. When they get to about maybe close to 63 hours, they cut. They don't want it there. And do you know that was why this is part of what you use to achieve what we call speaker management in digital mixing console. Before we use for crossover to cut our high, and our low. But since introduction of digital mixer, you can use this low pass and high pass to create what? Your crossover system for your speaker. It means that as the output of your high speaker, loudspeaker range, you use the low pass. So you use the high pass that let the high pass and you block all your low. So it means that some frequency will not come out from your top. Then for your sub, which is the woofer, then you use the low pass. You allow some frequency to pass at low. Then when it gets to, you know where you want to cut it, you cut. You roll it off. So it means that some frequency will not go into that low end. This is just simple achievement of crossover on the digital mixer. This is how to achieve a crossover on the digital mixer. And this is what we call speaker management. Yes, because your speaker management, this is what it does. So it means that from your output, you can select your output. You have, digital mixer have about 16 routable buses. You can pick maybe bus 1 and bus 2 for your top, and bus 3 and 4 for your low. And you go to the EQ on that particular bus and use your low pass and your high pass to achieve your crossover system. You don't need a crossover system. You don't need speaker management. You can easily use your digital mixer to achieve this. The same thing with high band pass, this band pass. Sometimes we have, we are very used to bi-amp. Yes, we call it bi-amp crossover system. There's tri-amp crossover system too, where you have the high, the mid, and the low. You can also do, if you want to achieve tri-amp, you can use the high band pass to achieve it. So it means that you are going to have your high frequency, you are going to have your mid frequency, and you are going to have your low frequency. So these three, low pass, high pass, and band pass, can be used to achieve your three-way bi-amp system for crossover sector in a digital mixing console. So I may not be cracking my head to be looking for speaker management to achieve this, because my digital mixer will do that for me. So the band stop and the notch, you can see all the frequencies, the way they are designed and the way they are drawn, which are very important in our daily use of digital console and the operation. So if you have a digital console, you will discover that you may not likely have to be moving any gears. The beautiful thing about digital console is that by the time you have it and you use it for an event and you're able to store and program, you can save on your flash drive that particular event. So when you want to set up somewhere again, you can use it as a dry test and also set up again. So you won't have issue with trying to set, because already you have a program, you have already programmed and stored in a flash drive, then you can easily recall it by inserting your flash drive back into your digital console and load that particular scene. And if you have done your setting, your low, if it is by amp you want to set, or if it's triamp you want to set, with your low pass filter, your high pass filter, and your band pass filter, you have already do the setting. So you know where your speaker cable will come out from before going to your amplifier, and you have to feed your speakers for low and for high. So these are part of things that are very, very important. You know, external EQ, external limiter, external gate, all those things. The digital mixer has already taken care of that. Speaker management, digital mixer has already taken care of that. So it's a one machine in all. Let me use that word. Just a single machine in all for all audio engineers. Once you have it, you will only move with your speaker and your microphone. You don't need any extra gears. That's just how technical and beautiful this digital console could be.